warahmatullahi wabarakatuh and salam sejahtera. This is an example of improving performance of Rankine cycle. So this is the problem. We have a steam power plant operating on ideal Rankine cycle. Steam enter the turbine at 3 megapascal with the temperature 350 degrees Celsius and condensate in condenser at pressure of 10 kilopascal. Determine the thermal efficiency of the power plant as given in TS diagram A. Next question is thermal efficiency if the temperature is increased from 350 degrees Celsius to 600 degrees Celsius. And next question is thermal efficiency if boiler pressure is increased from 3 megapascal to 15 megapascal but the inlet temperature is maintained at 600 degrees Celsius. So for the first question, okay, the solution is given here. Okay, first thing first, we have to know what is the equation that we use to solve this question. So for the thermal efficiency is given as W net over Q in. What is W net? W net is work of turbine minus work of compressor divided with heat addition. So WT is here. So H3 minus H4 minus work of compressor is here. So H2 minus H1 and Q in is here. H3 minus H2. So it seems to me that we have to find enthalpy for each state. State 1, state 2, state 3 and state 4. So first thing first, we find the enthalpy at state 1. At state 1, the pressure here is 10 kPa and we can see that the steam enter the entrance of compressor as a saturated liquid. So this is important for you to remember. Okay, so we refer to table A5. Since the phase is in saturated liquid, we find enthalpy at HF. Okay, and given here, the enthalpy at HF is 191.81 kilojoule per kg, and I also find specific volume VF, and the value of VF 0.00101 and the unit is meter cube per kilogram. So settle for H1. Next, I go to state 2. State 2, I use this formula. Okay, from our previous lecture, we know that work of pump is given as H2 minus H1, and also we know that the work of pump is V1 P2 minus P1. So by using this formula, okay, I rearrange so that I can get H2 as a V1 multiply with the differences of this pressure plus H1. Then I get H2 as a 194.83. Okay. So next, okay, so settle for H2. Next we go to state 3. State 3 as the inlet of a turbine and the temperature here is 350 degrees Celsius with the pressure P2 is equal to P3, that is 3 megapascal. So in this phase, in this state, you have to find the phase by sketching TV diagram or PV diagram. So by sketch the TV diagram and PV diagram, then you know what is the phase of state 3. So I already make a calculation that I find out that the phase for state 3 is superheated. So if the phase is in superheated, then I have to refer at A6 table. So from A6, I find the pressure 3 megapascal and temperature 350 degrees Celsius. So I get H3 as this value. And also I find the entropy. Okay, I have to find the entropy because S3 is equal to S4. Okay, so S3 is 6.7450 kilojoule per kilogram Kelvin. And please write it down as S3 is equal to S4 because it is related in state 4. So settle for H3. Okay, next we go to H4. So state 4 here. And again, we have to find the phase of state 4. Okay, so even though in this diagram, it's already sketched to you and you know that the phase is in mixture, okay, but it is a good practice for you to always try to find yourself how to get this phase. Okay, so we have pressure 10 kilopascal, P4 is equal to P1, and S4 is equal to S3 from this value 6.7450. Okay, and I look at table A5. At table A5, I look at the value of SF and SG. Okay, from the value, I find out that S4 is in between SF and SG. Okay, so that I know that the phase for state 4 is mixture. So if the phase is mixture, then I have to use special formula. Special formula given here as Y is equal to YF plus XYFG. And Y can be H, U, specific volume, and entropy. Since we have entropy here, then we replace S at this special formula. So it will get as S4 is equal to SF plus X4 as SFG. Then I get the quality at state 4 is 0.8128 or 81.28%. Okay, so I already have the mixture, then I can find H4. Using the special formula, I replace Y with H4. H4 is equal to HF plus HFG. Then again, you have to refer all the value at table A5. Okay, and replace all the parameters with the value that you get from the table, and X is from this value 0.8128. Then you will get H4 is 2136.1. Okay, and we already have H4. So by using this formula and put all the value H3, H4, H2, H1, H3 and H2, you will get the thermal efficiency for Rankine cycle for question 1 is 33.4% or 0.334. That's all.